Hey team, it's Mr. Z, and we're going to go ahead and look at some graphs. All right, so a couple of things I wanted to highlight is that this inequality, when it says p is less than 0, remember p of x is the same thing as saying when y is less than 0, it's going to be indicating a point that is below the x-axis. Notice the points that are above the x-axis are going to be positive. I also want to go ahead and tell you that when you're looking at the x values, you're going to want to go ahead and look at left to right. So we're going to scan this graph, and I can see that it's going from the edge of the graph somewhere, and it's eventually going to go all the way down to -2. Notice at this -2, at the x-intercept, it's not positive or negative. So to describe this behavior, we're going to say that from -infinity all the way to -2, it is decreasing. Or I'm not decreasing. Well, yeah, it is decreasing. That's a word we're going to use in the future. But p of x is less than 0 when -infinity to -2. It also is going to be positive. It's going to go negative all the way down until it hits 2, when it's going to be 0, and then it's going to go up to be above. So it's going to continue to be positive from 2 all the way to positive infinity. Notice how this parenthesis indicates that it does not touch 2. If you want to think of it in the form of inequality, remember when I said that x is greater than 3? That meant that at 3 it was an open dot going to the right. When x is greater than or less than 3, it was a closed dot, meaning it included 3. We are not including the -2. The other part is, let's go ahead and describe when it is below the x-axis. When p of x is below 0, when, oh, I got to change up my top one. I had my inequality going the wrong way. So let's look at it. It starts being negative after -2, and it goes until 2. Let's do a couple more problems. So let's look left to right, and I see that it goes from a negative. There is an x-intercept at 1, and then it's going to go positive. It's going to stay positive even though it's decreasing now because it's essentially still above the x-axis. I can see that there's a 0 at 3 and 5, and notice how the zeros are when it changes from a positive to a negative and vice versa. That's an attribute of a 0. So let's go ahead and talk about it. When p of x is greater than 0, it's starting at -1, and it's going all the way to 3. That's talking about this first region. Then it's going to start up being a positive again after 5, all the way off of the graph. Likewise, when p of x is less than 0, it starts the graph off at -infinity, meaning that it's going to keep on going until I hit -1. Notice how those zeros are these critical points. Then it's going to be negative again between 3 and 5. For the final graph, automatically find your zeros. Now ask yourself, what's below and what's above? Use the zeros to write out your interval notation. So the graph is always going to start from negative infinity and it's going to end up at positive infinity. Depending on where it is, it might be flipped. For example, here it was the same end behavior. Here, both of the end behaviors were pointing towards positive infinity. So let's go. When p of x, our function that we're looking at, is less than 0, it is going to go from negative infinity to 7. Then it's going to be green between negative 2 and 1. Then it's going to be green between 6 and 9. And when I say green, it's below the x-axis. When it's going to be above the x-axis, when it's going to be greater, well, it goes from negative 7 to negative 2. Then it's going to be connected union from 1 to 6. And then it's going to be connected from 9, and it goes all the way to infinity. It's never negative again. So just remember these inequalities. It's really just asking, hey, where on this graph is it below the x-axis and above the y-axis? I hope this helped.